Welcome to our first lesson on mathematics in the modern world. So our first topic is the nature of mathematics, and that's mathematics in our world. Our learning outcomes that would be to identify patterns in nature and regularities in the world, articulate the importance of mathematics in one's life, argue about the nature of mathematics, what it is, how it is expressed, represented, and used, and express appreciation for mathematics as a human. So Fibonacci is a mathematician who studied and investigated how fast rabbits could breed in ideal circumstances. So that was around 1200s. So suppose a newborn pair of rabbits, one female and one male, are put in a field. Rabbits are able to mate at the age of 1. So at 1 year old, pwede sila magmate and it can produce another pair of rabbits. So another pair of rabbits. So this is the original one. After a month, it can produce another pair of rabbits. So this one is still original. Another pair of rabbits. So that means there are already 2 more pair of rabbits. So the original pair of rabbits, which is this one, after the 3rd month, it can produce again another pair of rabbits. And a month after, the first pair of rabbits can now produce another pair of rabbit, while the original rabbit after 4th month can produce another pair of rabbit, and the 3rd generation can still be here and most likely can produce another pair of rabbits later on. So that is how Fibonacci's investigation works. So the puzzle that Fibonacci posed was that if we have this in our ideal circumstance, at the end of the 1st month they mate, but there is still only one pair. So they mate. So originally they're the one, and then they mate, and still they're one pair. At the end of the 2nd month, it produced a new pair, which is the one which I explain later, and so on and so forth. So that's Fibonacci sequence. So we look at the numbers, the number of pairs of rabbits here. We have 1, 1, then 2, 3 pairs, 5 pairs. It can also be applied with plants. If you're going to observe, example lang, the alugbate. So if you're going to plant a seed, diba na seed ang alugbate? So try to observe, or any other plant, observe the number of leaves that would sprout every day or every week. So try to observe. So in ideal circumstance, so 0 pa, wala pa ni. Then ni produce another one leaf, then 2 leaves, 3 leaves, 4 leaves, 5 leaves, 6 leaves, and so on and so forth. So try to observe the plants around you. I know all of us have plants around, so try to check and observe the growth of the leaves of the plants. So this can be represented in geometric manner. So we start with kining mga very tiny squares. So we have square 1 and another one. So kining 1 og 1, ang ihang side ani mo produce na og 2. So, dapat square man ang atong i-create. So, 2. So, you have 2. And kining 1 og ang 2, mo create na siya og 3 ka squares here. Sides sa squares. So, nanatay 3 dinhi. So, si 3 plus duha ka 1, maka-create na ni 5. So, kung 5 ni dinhi, 5 sa ni dinhi. So, 5 plus 1 plus 2, that's 8. So, 8 ni siya. So, naatay 4 squared or 8 dinhi. 8 ka sides. Sides na siya. So, kung 8 ni plus 10 plus 3, so, ang kini nga side is 13. So, 13 ni siya, 13 ni siya, 13. So, kung 13 ni plus 3 plus 5, then that will give us 21. So, kani 21. If ato pag yun siyang padakon, si 21 plus 13, pila man na siya? 39. So, nasa tayo 39 dinhi dapita, and so on and so forth. So, Fibonacci number is an integer in the infinite sequence. Nganong infinite man? Infinite means it will not end, it will not stop. There is forever and infinite kana siguro. Mas dali na siya sabton. So, naatay 1, 1, 2, 3, 5, 8, 13, 21. So, ang sum sa first two gives you the third. The sum of the kini siya, here na lang. So, 1 and 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 8 is 13, 8 plus 13 is 21, and so on and so forth. So, it will continuously have a term, a number after it. Kay pwede raman gihapon ani mo ma-add ang preceding two numbers. Preceding meaning nag-una nga duha ka numbers. So for the golden mean, it's a very special number, ang golden mean. So maybe you are familiar with it, or you have seen some pictures, and may have not associated it as golden mean. Ang golden mean daw is found by dividing a line into two equal parts. So natay usa ka line, i-divide na into two parts but not necessarily equal, A and B. So i-divide na to daw si A over B, that would be equal to A plus B divided by the length of A. So, mana siya ang golden mean. So, you have to be very careful here. So, the longer part, kini mas dako man siya, the longer part divided by the smaller part is equal to the whole over A. That's the golden mean. So, let's see some examples. So, it can be applied daw in our body. So, very ang atong body, very geometrical. So, if ang imuhang ratio sa imuhang arm, kini, asa may mas taas ani. So, mas taas ni siya din hidapita kaysa ni. So, the longer part divided by the smaller part, i-measure nimo ang whole divided by the longer part. If very close na siya to 1.618, it means you have a perfect body. So, I think we did this when we had our MA nga nag-measure gud mi sa mga body parts, and then among gi-compute kung perfect body ba gud mi. So, maybe you can try this if perfect body ba gud mo. So, in mathematics, dili measure ang perfect body sa waistline, bust line. So, mathematically, we will be following the golden ratio if you want to see the perfectness of one's body, the beauty of one's body. So next, fractals. So I'm not sure if you have encountered these terms in your senior high. So fractals daw is a rough or fragmented geometric shape. Rough kayo. Kanang sa Bisaya ana di ko kuan sa Bisaya. Yeah, fragmented daghan kaayo kanang na di ko kabaw sa Bisaya. Shape that can be divided in parts, each of which is a reduced size of whole. Diba? Mao ni siya ang whole nga broccoli. If imo ning tangtangon, ginagmay, mura siya dagwaya sa tibuok. So, kung kini pinutol ni siya, kung iput na nimo together, mura gihapon na siyang naunga. It's just the size lang. So, nag-anam siya kagamay. So, imo na siyang, lami ba kini siya, so, if imo na siyang tangtangon, kwaon, putlon-putlon, it means that it still looks like the bigger part of it. So, that's fractals. Let's see another example. O ang fern. Sa Bisaya, pako. So, tanawa. If you have ferns around your house, you look at it. So, kung mo ni siyang hole, kung imo ni tan-aw kini siya, mura ra gihapon siya dagway sa ani hole. No? Tanawa. So, that's fractal. So, a fern is a fractal. So, geometrically, in the size, the shape, no, not the size. The smaller part is the same as the bigger part, meaning liwat ra gyud gihapon na sa kinikanan kung baga ato ang hyperbolic nato or say tawag ana sa English nga liwat ra gyud siya, mao ra gyud siya. Whatever you have in the smaller parts, that's exactly how it look like sa bigger part. Next, spiral. So spiral is a curve pattern that focuses on a center and a series of circular shapes that revolve around it. So if you mong tanaw, nakadiri, nagsugod ka, maana na, matuyok, tuyok, 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 tuyok. So pari, naana siya, maka-create kag spiral aning pinya. So another example, kini. Oh, very recent lang si Odette. So if tanaw na to ang super typhoon, na siya ay sa typhoon. So, nag-create siya spiral. Inana, mo na nang lupad ang atong mga atop. Kay kusog kaayo to si Odette. So, the shape of the typhoon nga na siya ay magtuyok-tuyok man na siya ang bagyo, ang hangin nga naka-create sa bagyo. So that's this picture is also a spiral. So next, Voronoi, something new. So ang mga Voronoi, mga term na to something new, but ang mga objects nga atong makita are just found around us. Kini siya lami, kini siya. It's one of my favorite food, ang sweet corn. So, a Voronoi pattern provides clues to nature's tendency to favor efficiency. So, ang nearest neighbor daw, so, kini siya nearest neighbor nimo, shortest path, tightest fit. So, each cell in a Voronoi pattern has a seed point. Yan niya. Everything inside a cell is closer to it than any other seed. So, tanaw na nimo dito ang ilawom gyud ana. Very close kina sila. And the lines between are always halfway between the neighboring seeds. So, ang iyahang kuan ani niya, kuan na gini siya halfway. Halfway. The distance from this to this is equal to half. Kana. Siya Voronoi. So, another example sa kini o honey. Lami kining honey. Kini siya, distance ani niya to here. Mani siya. Kini siya, distance niya to here. So, very close na siya ang Voronoi. So, There are a lot of shapes and patterns around us.